Just like we can establish upper bounds, we can also establish lower bounds. So let's take a look at this polynomial. And first let's think about what its roots might be. Positive, 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 positive. This polynomial has no sign changes, so it doesn't have any positive real roots. I just threw out half the possibilities that I might have tried. That's pretty cool. If we plug in negative x for x, right, so we're doing that p of negative x thing, we're going to reverse the signs of everything with an odd power of x. And leave the ones with even powers alone. So that has 1, 2, 3 sign changes. We have either 1 or 3 negative real roots. So we know we're going to have at least one negative number. So we should think about trying, well, negative numbers, right? What have we got? Well, so our leading term is 3. Here are the factors of 3. Our constant is 4. Here are the factors of 4. So we have 1 over 1, 2 over 1, 4 over 1, 1 over 3, 2 over 3, and 4 over 3. And that's it. And ordinarily I'd say we have the positive or negative versions of each of these, but we already saw we don't have any positive roots, so really we only have the negative versions. We like integers, so we're going to try negative integers first. And let's see what's happening. So when we try to do synthetic division with negative 1, 3 times negative 1 is negative 3, plus 4 is 1. Times negative 1 is negative 1, plus 13 is 12. Times negative 1 is negative 12, plus 4 is negative 8. Hey, was everything there positive? Right, we might think that negative 1 is an upper bound. But actually that doesn't work for 2 reasons. The most important one, and the one I want to make sure to highlight, is that our upper bound rule can only establish a positive upper bound. And also, the negative 8 was negative. So even if we had been working with a positive number, that remainder being negative still means that we aren't following that upper bound rule. Okay, so we don't have any bounds yet. Let's keep going. 3 times negative 2 is negative 6, plus 4 is negative 2. Times negative 2 is positive 4, plus 13 is 17. Times 2 is negative 34, plus 4 is negative 30. Right. We notice that the signs are going back and forth, but our numbers are getting big. And that happens even more with negative 4. The signs do what's called alternating. Right, so the signs are going one positive, one negative, one positive, one negative. And that's happening when we're plugging in a negative number. And that's what's going to signal that we have a lower bound on our hands. If we have a negative number k, and when performing synthetic division, the terms of the quotient and the remainder alternate signs, then k is a lower bound. So every root of the polynomial is greater than or equal to k. In our example, we alternated signs when we had -2. So -2 is a lower bound. Every root is greater than or equal to -2. So we didn't need to try a -4. What possibilities do we have left? Well, let's look at our fractions. It turns out all of these negative fractions are in fact greater than or equal to -2. So -1/3, -2/3, and -4/3 are still possibilities. Those are the only possibilities, though. We know that we only have to try 3 more things, and either we'll have found a rational root, or we'll know there aren't any. And knowing there aren't any is actually just about as useful as having found one. In this example, there is one, but I will leave trying those to you.